class, and welcome to the Chapter 3 review. So Chapter 3 review today. First things first is I want to go over the Chapter 3 rules. So we're going to talk about the Chapter 3 rules. As we know, there was really only 3 rules that we learned about in this chapter. We only learned about 3 things. So who would like to raise their hand and tell me the first rule, the only rule when we add and subtract decimals? Lila, what do you think the first rule is? Let's see, Dolan, what do you think?
The rule when you're adding and subtracting is you have to always not line up the decimals.
Yes, always line up decimals. So when we add or subtract, you were right, we actually always add and subtract the decimals. Great. Amelia, what is the rules when multiplying?
Always line up the numbers to the right.
Perfect. So we line up the numbers to the right. And then I'm just going to put normal, because that's how we do it. Lucas, what's the next thing we do?
You also, when multiplying, however many times you move the decimal to the right, you also have to move it the same amount of times to the left once you've finished your problem.
Perfect. Bunny hop decimals to the right. Multiply. And then we move decimals back the same amount.
Also, don't they not
Marley, what's the rule when we divide with decimals?
always bring up the decimal?
That's true. That's one of the steps. Yes. So we do bring up the decimal directly. Yes. Cynthia, do you know what comes before that?
Your divisor not have a decimal?
Yes, as I'm writing in highlighter. The divisor cannot, that was me trying to spell cannot, have a decimal. I'm going to move this up a little bit so that I have room for this. The divisor cannot have a decimal. You move divisor and the dividend decimals the same amount of times to the right. And then, as said earlier, all we do is bring up the decimal. That's it. So those are the 3 rules that we have here. Those are the 3 rules that we have. Add and subtract, you always line up the decimals. Multiply, you line up the number to the right, just like normal. We bunny up the decimals to the right. Multiply and move them back the same amount. Divide, the divisor cannot have a decimal. We move the divisor and the dividend decimals the same amount of time to the right. Then we just bring up the decimal. Perfect job, you guys. So let's see. Here's this first one. 4 9/10 plus 3. 4 9/10 plus 3. I want you guys to do it on your paper. First things first, I want to ask you guys, this is an addition problem. So am I going to line it up like this, where I line them up all the way to the right? Or am I going to line it up like this, where I just kind of have them looking a little bit weird right now? But which one? Hit the go slower if you think that it's this one, and hit the go faster if you think that it's that one. The majority of you, although only 2/3, said that it is this one. You are correct. But wait, I'm curious, 3 doesn't have a decimal, so there's nothing I can line up. Wait, what do I do, Lila? Why do I line it up that way?
I'm not sure, but I did
Lucas, why do I line it up like that? 3 doesn't have a decimal.
because you gotta put a decimal after. You gotta put a decimal after.
Right? Like that?
We gotta put a 0.
But how do we know that that's where the decimal goes? Why can't I just put the decimal right here? You know, we're just putting it wherever I want, right?
always have to line up the decimals.
But also I can't put it in front because 3/10
So,
is not the same as 3. Those are not the same as 3.
that
So
would be 3/10, and that's just 3.
exactly. So I want to give everybody credit in the chat. We just add things like normal now. 9 plus 0, we get 9. We have 4 plus 3, we get 7. So I get 79 as my answer, right? Thumbs up, thumbs down.
Forgot the decimal.
Thumbs up. Ah, yes. We just bring the decimal straight down. It's supposed to look nicer, but we bring it straight down. So I get my answer to be 7.9 or 7 9/10. I want you guys to try this one. I want to give credit, by the way, to the people who got it in the chat from the beginning, because a lot of people did. So we had Lila, Pearson, Jackson, Cynthia, Gio, Romina. We had Dolan. We have, let's see who else. Kayla. We have, let's see who else I'm scrolling down. We had Camilla. We had Lucas who got it. We have Ella who got it. Vahe got it. Exactly, Cynthia brought up because 3 is a whole number. So she mentioned that's why the decimal is there. So excellent. Here's this problem, you guys. I want you to line up this problem. So as I was talking, a lot of you ended up getting 5.2. Now our correct answer is 7.9 or 7 9/10. The people who got 5.2, it's because you lined it up like this. You lined it up to the right. But when doing addition and subtraction, we have to line up our decimals. This is not. Our decimal is here because 3 is a whole number. Whenever we have a whole number, the decimal goes at the end. So yeah, if we were adding 3/10, then that would work. But 3 is a whole number, so the decimal goes at the end. So this one's a lot easier to line up, right? Our decimals, I'm just going to put 24 and 36/100ths. And it's super easy to line up my decimals right there. Our decimals are now in a line. I'm just going to bring it straight down. So Ella, what did you do now?
What I did is I plused everything, and 6 plus 3 is 6. 9.
Yep.
9. 3 plus 6 is 9.
Yep.
4 plus 5 is 9.
Yep.
And 2 plus 1 is 3.
Excellent. And everybody who wrote it in the chat got it correct. Camilla got it correct. Cynthia got it correct. Dolan got it correct. Amelia got it correct. Ella, who did this, got it correct. Pearson got it correct. Lucia got it correct. Lila got it correct. Romina got it correct. Jackson got it correct. Some people were just a tiny bit off. Lucas got it correct. So we see all of that. What about this one? Now I'm doing a subtraction problem. So I want you guys to try this, subtraction. So I'm going to line up my answer, right? So I'm going to write it right here, and then I'm going to put it like that, right? We all agree that's how we do it? Thumbs up, thumbs down. What do we think? That's how we line it up when we're doing this? No, I'm getting a lot of thumbs down. Oh my God, I guess I don't know what I'm doing. Oh my God, Ella, what did I do wrong?
You have to put the 12 under the 4 and line up the decimal, and then put a 0 after the 4.
Ah, yes. So I line up my decimal, and then there was no number. And remember, when there's no number, what number is it?
0.
0. Delaney, what is 9 minus 0?
9.
It is 9. 3 minus 4, Delaney, can I do that?
No.
So what do I have to do?
You have to cross off the 3 and make it 13, and then you cross off the 4 and make it 3.
Excellent. What is 13 minus 4? What is 13 minus 4?
9.
Perfect. 9. I'm going to drop that decimal down. Ignore my multicolor. 3 minus 2? And then 1 minus 1?
0.
Perfect. So I simply get
199.
199. 1 and 99 hundredths. 1 and 99 hundredths. In the chat, like I say, because I love giving credit to everybody. The people who got it were Lila, Lucia, Ben, Amelia, Camilla, Cynthia, Pearson, We got Gio, Ella, Jackson, Delaney who answered this. We have also Vahe, and we have Sophie and Sophia and Lucas who got it. So excellent, you guys. You guys did great. This one is a multiplication problem now. This one's a multiplication problem. So I'm going to line it up for us, right? Let's line it up. So I got 2 and 48 hundredths and 8. Awesome. Right? We Gucci? We Gucci? Oh, no, I see a lot of you guys shaking your head. I see Lucia saying no. I see Lucas with his hand down. I see all that Hannah shaking her head. No, what did I do wrong, Lucas? What did I do wrong?
You don't always have to line up the the decimals with multiplication, so the 8 would technically go where that other 8 is in the back.
Yeah.
Move it.
With multiplication, exactly, he brings up, we line it all the way to the right. We line it all the way to the right. Sophia, what's my next step?
Okay, so now you gotta see how many decimal places there are, which there are 2.
Perfect, so I bunny hop it 1, 2. Do I need to bunny hop the bottom one at all?
No.
No, so I just have 2 bunny hops.
Yeah.
And then I just solve like normal, right? All I do is multiply like normal. Cynthia, what did you do? Walk me through it.
So first I multiplied 8 times 8.
Which is?
64.
Perfect, so I'm going to put a 64 like that, right?
Now you put the 4 on the bottom, and then you put the 6 on top of the 4.
Okay, perfect. Then what do you do?
And then I multiplied 4 times 8.
Perfect, and what'd you get there?
34.
Excellent. So we got not, it's not 34, it's what?
40.
Well, true, it's so we get 32, and then what? So I just put my 2 down here?
Now you have to add the 6.
Oh, I add the 6 to it. So I get 38. I carry my 3 like before. What's 8 times 2?
16.
And then I add the 3 and I get?
19.
19. So I just drop this decimal down, right? That's how it works?
Now you have to bunny hop the to the
Oh, I have to bunny hop 2 to the right. Even though it happened to work with that problem where I brought it down, Cynthia, is it always going to work when I just bring the decimal down? No. So don't think about that. Always think about our bunny hops. So we get 1984, which is pretty applicable for this year. Camilla got it. Lila got it. Amelia got it. We got Lucia got it. Sophie got it. We have Gio who got it. We have Vahe got it. Ben got it. We have more people, so we got that. Excellent. We have this one too, you guys. We have this one. Which number do you want to write on top? Do we want to write the first number? And now it doesn't matter with multiplication, but let's think about it. Do we want to write the first number on top? Give me a thumbs up for it being on top. Or do we want to write the second number on top? Give me a thumbs down for that. What do we think? Which one of the numbers? Do we want to write the 0 and 198 10,000ths at the top or the 75 on the top? Which one do we think? You want to write the 75 on the top, you guys? I heavily suggest that you write the one with more digits at the top. Are you going to get the answer wrong either way? No. As long as you do the math, you're going to get it right. But I heavily suggest you write the one with the more digits. As I was saying, I highly encourage, I always suggest writing the more digits on the top. So if I lined it up, personally, I would write it like this. But isn't this 36 times 3 the exact same as 3 times 36? Aren't those the exact same thing when we line them up? Yeah, they're the exact same thing. So it doesn't really matter how you write it, as long as you know how to write multiplication problems. When I'm working with decimals, I like to draw this little thing on the side to help me just remember that I'm doing it. On your fingers, how many times do I have to move the decimal? On our fingers, how many times do I have to move the decimal? Ooh, I've got a couple good students. Ooh, I've got it. Yes. We move it 4 times. We move it 1, 2, 3, 4. And then I'm done. I like to put my 4 there just to remind myself so I can see it. I like to put my 4 there. Now, I would like Amelia to walk me through this problem.
Okay. Let me just get multiple.
So what do we get? Okay, so what do we do?
Okay. So what you do is So first you have to multiply the 5 with the number, you have to multiply the 5 with the number that's on top. So 5 times 8 is 40, and then you bring the 4 over the 9.
Perfect.
And then 5 times 9 is 45, but you have to add 4.
So what do we get?
Which is,
Perfect. So we get 49. The next.
and then you carry the 9.
We carry the 4.
The 4, sorry.
And then 5 times 1 is?
5 times 1 is 5, and then 5 times 4 is 20.
So 5 times 1 is 5, and then we add that 4, and we get 9. Do I need to do 5 times any of the zeros? Does it matter?
No.
Now, so what do I do now?
Okay, now you do 7 times 8.
Wait, is she forgetting something, you guys? Is she forgetting something? I want to know, Vahe, what is she forgetting? Cynthia, what is she forgetting?
She's forgetting 0.
She's forgetting our magic 0. Yes. Okay, then continue, Amelia.
I knew I was forgetting.
I knew you were. Continue.
Okay. And then 7 times 8. Oh, wait, but
Mhm.
the trick is, erase the 4s. So 7 times 8 is 56.
So I'm going to put my 6 here, my 5 here. Perfect.
And then 7 times 9 is 63.
Perfect.
And then you add 5, which is,
So we add the 5 to the 63 and we get?
6, wait.
Perfect. So we get 68. And then our last step?
And then 7 times 1, which is 7, and then 7 plus 6 is 11.
7 plus 6 gives us 13. Perfect.
13.
Now, I'm going to add these together. So I'm going to add these ones together. I want, Lila, can you add them together for me? Let's start adding.
Wait, why is there a smiley face? Okay.
So 0 plus 0 is?
0.
9
0.
plus 6 is?
15.
Perfect. 1 plus 9 plus 8 is?
Sorry.
Is 18. 1 plus 3 is?
4.
And then 1 plus nothing is?
1.
Perfect. So my answer is 14,850, right? Whoop, whoop. We finished. We're done with this. 14,000. No. Why not, Lila?
You have to put the decimal.
I have to put the decimal back 4 times. So I'm going to move it. 1, 2, 3, 4. So I get my answer to be 1 and 485 thousandths. You could also include the 0 at the end, but do we need that 0 at the end? No. If it's after the decimal and it's at the very end, we don't need it. The people in the chat that got it correct were Camilla, we got Cynthia, Pearson, Abner, Sophia, Gio, we got Lucia, and Lucas who got it. So let's look at this one. This one's a two-parter. The melting point of sodium is 97 8/10 degrees Celsius. The melting point of potassium is 63 65/100 degrees Celsius. How much higher is the melting point of sodium? What am I going to be doing here? Addition, subtraction, multiplication, or division? So I want you to take a guess. So using the participant section, I want you to take a vote. You're going to hit yes for add, no for subtract, slower for multiply, and faster for divide. Actually going to subtract. Camilla, how did you know we were going to subtract?
I knew we were going to subtract because the question says how much higher is the melting point of sodium.
Ah, so she saw our keyword, how much higher is it? We're trying to find the difference between the two of them. We're trying to find the difference between the two. And difference means subtraction. So, let's see. We're going to set this up. We're going to set it up to 97 and 8/10. And I'm going to subtract 63 and 65. Did I line it up correctly? Thumbs up, thumbs down. Did I line it up correctly? What do we think? So I did line it up correctly because I lined up my decimals. And I can just drop that decimal down right there. I can just put that decimal down right there and I know I'm doing it correctly. When there's no number, exactly, Camilla even answered it. When there's no number, I have to add a 0. So I want to do the math. Ben, can you walk me through this?
Anyways, yeah.
So 0 minus 5.
0 minus 5 is...
Can I do that?
You cannot do that, so you have to borrow from 8 and make it 10.
Perfect. Turn the 8 into a 7 and turn the 0 into a 10. Perfect. Now what do I get?
You get 5.
Perfect. Next.
6 minus 7 equals 1.
So 7 minus 6 is 1. We had dropped down our decimal already because we're doing subtraction. Next step.
7 minus 3 equals 4.
And then?
9 minus 6 equals 3.
Excellent. Great job, you guys. And that's all it takes when we're doing subtraction. So the people in the chat that got it correct, as we saw, we got Camilla, we got Cynthia, we got Sophie, we have Romina, Lucia, Abner, and Lucas who got it so far. And that's just who put it in the chat. So perfect. As we see, the melting point of sodium is 34 and 15/100 degrees Celsius higher. The word higher is talking about a difference. If you're higher in height than your brother, then you're trying to find the difference in your height. Let's look about this one. Izzy's incredible library has 9,440 nonfiction books. She wants to split the books evenly among 80 shelves. How many books will be on each shelf? So how many books will be on each shelf? The first thing I have to figure out, who would like to raise their hand and tell me what operation am I doing? The operation means addition, subtraction, multiplication, division. Romina, what am I doing?
I think you're gonna do division.
Why'd you pick division?
Because it says that Izzy wants to split.
Yes, our keyword is split there. When we split something, we're dividing it. Excellent. So perfect. We already know we're going to do division. Which number is going to go on the outside? Which number is going to go on the outside of the house? Who can tell me which number? I want to call on Pearson. Pearson, which number is going to go on the outside of the house? Yes, so 80 is going to go on the outside of the house, meaning that is going to go on the inside. When we're talking about splitting, it means this, 9,440 divided by 80. And as we know, our first number, it rushes ahead and gets to get inside the house. Our second number has to wait. So our first number gets inside the house. So I want you guys to solve this. Question, do we have to do anything before we start our problem? Do I have to set anything up, do anything before I start my problem? What do we think? Use the participant button. Do I have to move any decimals, line anything up? Do I have to do anything? No, I don't have to do anything. There's no decimals, so it doesn't matter. I'm going to call on Vahe. Vahe, how many times does 80 go into 9?
0.
Perfect. What about 80 go into 94?
1.
1. That's 80. What do I get when I subtract?
14, and then drop down to 4.
Perfect. I bring down my 4. How many times does 80 go into 144?
1.
1 time. I subtract 80. And what do I get?
You get 64, and then you drop down to 0, 640.
And how many times does 80 go into 640?
8 times.
And what is that what is 80 times 8?
118.
Exactly, because we would get 640 right here. We subtract and we get 0. So our answer, perfect, is 118. Excellent. So in the chat, we also had Camilla who got it right, Lucia, Sophia, We had Ben who got it almost correct. He added an extra 0 at the end. It was a typo. Amelia got it correct. So there's all sorts of things. This one's a little challenging. It asks you to find the area of the figure. It asks you to find the area of the figure, and I didn't even mark down one of the things. How do we find area of figures? How do we find area of things? Who would like to tell me? Or else I'm just going to call on someone random. Let's see. Lucia, how do I find area of figures?
You multiply.
I do multiply, yeah. So I have to multiply our length times width. But here, it's a little bit complicated because there's technically 2 rectangles, and I need to find how much they are. So the first rectangle, this bottom one, is going to be pretty easy. This first one's going to be pretty easy. The second one is going to be like a little bit more challenging because we don't know one of the measurements, but we'll be able to figure it out. This is technically a 3-ish part question, maybe even 4. So our first step, I want to find the area of the easy rectangle. Has anybody found the area of the easy rectangle so far? Has anybody found the area of the easy one? Eduardo, what did you get? So this one's a bit of a multi-step. I want to find this one. I do length times width, which means 6 9/10 times 3 1/10. I'm going to have to bunny hop because it's multiplying, because that's how we do area. 2 times. 1 times 9 is 9. 1 times 6 is 6. Magic 0. 3 times 9 is 27. 3 times 6 is 18. Plus 2 gives me 20. I'm going to add these together. I'm going to move this up so we got room. I get 9, 13, 1, and 2. And then I got to bring my decimal back, 1, 2. So the area of this first rectangle is 21 39/100ths. But I got to find the area of my other rectangle. This one's a little complicated. I know that one of my sides is equal to 3. But what about the length of my other side? Who can tell me what the length of my other side is? Because it's not 6.1. That's the length of the whole thing. It's not 6.1. So what is the length of that other side? I'm going to give you a hint. If this whole line is 6 1/10 and this is 3 1/10, what's the remainder going to be? Because I've got this. Not an actual remainder, but this whole thing. This whole part is 6 1/10. This is 3 1/10. I need that to become 6 1/10 when I add them all together. So the way that it works, I'm going to do 6 1/10 minus 3 1/10. I lined up my decimals. It just worked. I get 3. So this side is just 3 inches. Do we understand how that happened right here? This side is a little bit more complicated. I don't think I have a problem fully like this on my test, but it's just to see that we can do all of the steps. Because look, this side is 3 and this is 3.1. We add them together, we get 6.1. 3 times 3 gives me 9. 3 times 3 gives me 9. What's my last step that I have to do with this problem? What's my last step, Camilla? What is my last step?
Your last step is to add.
Yes. Perfect, because now I have to add my area together. So I'm going to do 21 39/100ths and 9, right? Camilla, I did that right?
Under the 1.
Oh, I have to put the 9 under the 1, Camilla, right? Because we line up our decimals. And then what do? I don't have any numbers. What?
You add zeros.
Zeros. When I have no numbers, it's zeros. I add these together. 9 plus 0, 9. 3 plus 0, 3. I bring my decimal straight down because we're adding. 1 plus 9 is going to be 10. I carry my 1. 2 plus 1 is 3. So the area of my shape is 30 39/100ths. The reason I wanted us to do this problem is because it included addition, subtraction, and multiplication. Now I've got this problem, you guys. Let's see. Which number goes inside the house? I want to know which number goes inside the house. Jessica, take a guess which number goes inside the house. Yes, Jessica, we get 20 and 4/10. So 3 is on the outside. Do I have to move any decimals? What do we think? Nodding our head or shaking our head. Do I have to move any decimals? What do we think? I do not have to move any decimals because the only one that can't have a decimal is our divisor right out there. And it doesn't have a decimal, so we're Gucci. Then, with my division, once I'm done and I don't move my decimals anymore, once I'm done and I don't move them anymore, Kayla, what do I do with the decimal that I have in my house? What do I do? What I do is I just bring it straight up. Perfect, that's it. And then I start doing my problems. Perfect, Ella, how many times does 3 go into 2?
I wasn't done bouncing. 3 goes into 2. You can't do that.
Can't do it. Perfect. What about 3 into 20? 6 times, because we get 18. We're going to subtract, I get 2. What do I have to do now?
You can't see anything with these. 4.
Perfect. And how many times? Oops. 8 times. That's 24. I get 0. So yes, we get 6 and 8/10 in the chat. Camilla, Cynthia, and Amelia answered it in the chat. Not saying anybody else did it, but that's what we got so far. How about this one, you guys? This is a big number. 326 and 12/10 divided by 31. Divided by 31. Lucas, I want you to set this up for me. What number goes inside the house?
326 and 1200.
Look at this. Great academic language. So our 31 goes outside. What do I do with the decimals?
Well, what you do with the decimal is like on the very top where your quotient would be, you put the decimal where that would be.
Look at, he's using such academic language. Where the quotient would be, I just bring my decimal up. Because did I have any decimal to move with my divisor?
No.
Nope. So we're good. Excellent. So that's how we set up this problem. So Abner, how many times does 31 fit into 3?
I'm pretty sure it can't.
Yeah, it can't. How many times does 31 fit into 32? It goes in 1 time. That's 31. What is 32 minus 31? So when we subtract 32 minus 31, we get 1. We bring down our 6. Abner, can 31 fit into 16?
No.
No, it can't. So then we bring down another 1. I'm going to tell you, it fits in there 5 times. So 31 fits in there 5 times. That gives me 155. I subtract and I'm going to get a 6. I bring down my 2. When I bring down my 2, I think how many 31s go in? 2 of them go in. It's exactly 62. So we get 0. Our answer is 10 and 52 hundredths. So it's a continuation from last time. What we're doing is long division. Who would like to raise their hand in the participant section and tell me which number goes inside the house? Vahe, which number goes inside the house?
6.4.
Jessica, what do you think about what he says?
120 that goes inside.
She thinks it's 120. So thumbs up for being 120, thumbs down for being 6.4. Let's think about that. What do you guys think? Raising our hands. It is 120 goes inside the house. First number goes inside the house. First number goes inside the house. So, remember, think about it like this. If you're the first one to get out of the car, you just run, and then you're the first one in the house. First one out of the car, first one in the house. So we got the 6 and 4/10 on the outside. 6 and 4/10 on the outside. But can I just start doing my long division? Can I just start it right now? No, I have to do something. Camilla, what do I have to do?
You have to move the decimal for 6.4.
Yes. Ella, why do I have to move the decimal for 6 and 4/10 specifically?
Because I don't know exactly.
Exactly, Ella. We can't have our divisor, our outside number, have a decimal. But I moved this decimal. That's all I have to do, right? I moved this decimal. That's all I have to do. I don't have to do anything else. Romina, what do I have to do? I moved my divisor's decimal. What am I going to do?
See if how many times 6 or 4 can go.
She was giving a step, but she's getting it. Marley, what do we have to do?
We have to put it on top of the house.
Not yet. We're so close. We're all skipping one step. Lucas, what is it?
Gosh, I was gonna say what Marley said, but I feel like you should maybe put like a decimal like on the way back of the 120. Like after 0. Yeah, that's what I thought.
And then? And then Camilla, what do we think?
I think you need to add an extra 0 because you moved it.
Yeah. So with division, we have to move it the equal amount of times. So if I move it once on the divisor, I have to move it once on the dividend. If I move it 1,000 times on the divisor, I have to move it 1,000 times on the dividend. And when there's no number, you guys, what number is it? It's 0. Excellent. And now you just bring the decimal straight up, just like Lucas, just like Marley, just like Romina were saying. Perfect. And then you just long divide. Camilla, how many times does 64 go into 1?
64 goes into 10 times.
What about 12?
Also 0.
Oh my god, more zeros? Okay, what about 120?
1 time.
1 time. That's 64. When you subtracted it, what did you get?
I got 55.
56.
Yeah.
And we bring down our 0. How many times does it go into 560?
8 times, and you get 512.
So we get 512. We subtract, we get 48. So I'm completely done, right? Because I ran out of numbers, right? No more zeros. What do I have to do then, Camilla?
Gotta add zeros and then bring them down.
So here's my decimal and gotta add more zeros. I'm gonna bring it down. Camilla, how many times does it go into 480?
7 times.
Perfect. It goes in 7 times. And what is that?
448.
Perfect. 448. We subtract, we get 32. I still have to bring down more zeros. And then lastly, how many times does it go into 320?
It goes in 5 times evenly.
5 times evenly. Excellent. So we find out these zeros in the front, we don't even need to care about them. And we find out it is 18 and 75 hundredths. 18 and 75 hundredths. Let's look at this problem. Miles's submarine sandwich is 1.5 feet long. He cuts it into 2,500th foot pieces. How many pieces will he have? So first of all, what I want to know is what operation we're doing. What operation are we doing here? Amelia, what is the operation we're going to be doing?
Subtraction.
Why do you say subtraction? Just taking a guess?
Huh? Yeah.
Vahe, what do you think? Your hand's up.
Yeah.
What do you think? What operation do you think we're going to be doing?
To the seams of it, okay, so she has
Lucas, what operation do you think we're going to be doing?
Addition.
You think we're going to be doing addition? Marley, what do you think we're going to be doing?
Yeah.
I think we're going to be doing subtraction.
She thinks subtraction. Funny enough, none of you have gotten it right so far. I'm going to highlight a word. The word is cuts. He cuts it. Romina.
Division.
Yes, we are doing division, but Romina, is that what you were going to say?
Yes.
Perfect, Romina, for raising her hand. So we're going to be doing division. My first number is my sandwich that I'm cutting into that many pieces. So which number then goes inside the house, Marley? Which number goes inside the house, Marley?
105.
Perfect. 1 5/10. So as we know, the 0 and 25 hundredths goes outside of our house. It goes outside of our house. But I'm not done yet. I can't just do this. I can't leave it like that. Remember, with dividing, our divisor cannot have a decimal. So on your fingers, how many times do I have to move the divisor's decimal over? On your fingers, how many times do I have to move the outside number, the divisor's decimal, over? So on your fingers, can you guys show me? We move it over twice. Here's the decimal. We go 1, 2, and we're done. But as such, we also have to do the same exact thing to the inside. 1, 2. So I put my 0. So essentially, you guys, what I'm doing is I'm dividing 150 by 25. So Marley, what did you get as your answer?
I got 6.
Yes. And if you're having trouble, whenever you have like a 25, think about money. Think about quarters. Think about how many quarters go into $1.50. Think about how many quarters go into $1.50. So he will have 6 pieces. Here again, we're doing some division. Oh my gosh, it looks like a big number, but we're gonna see what happens. Ben, what number goes inside the house? The first one or the second one? Ben says the first one. Yes. And the second number goes outside the house. I know I'm going to be antagonistic, but Marjorie, how many times are we going to move the decimal for this number? I don't want the decimal, so how many times am I going to move it over to get rid of it?
1 time.
1 time, exactly. So we're going to do, what do we do with that, Marjorie? What do we do next? Because we moved it in the divisor, so what are we going to do?
From the number inside of the house.
Yeah, we just move it over 1 as well. And I'm just going to bring it right up. Perfect job. Perfect job. So now we have to figure out how many times 34 goes into 1 and 6,728 10,000ths. 1.6728. Several people wrote the answer in the chat, which was really, really awesome. We got Camilla as the first one, but I want to go through this together. This first 0 we don't even need to care about. It's now 1.6728 or 1 and 6,728 10,000ths. 34 does not go into 1. 34 does not go into 16. But 34 does go into 168. 34 does go into 168. And it goes in 4 times. That's 136. If you're having trouble, just skip count. Just skip count. Just add. So then we do the subtraction. 7 minus 6 is 1. 6 minus 3 is 3. 1 minus 1 is 0. Okay, we bring down our 2. Excellent. Once again, if we were doing skip counting, 136 is 4 times. This is more than double. So I'm going to think, okay, maybe it's 8 or maybe it's 9. And it's not 10 because it's less than 340. Turns out that it is 9, which is 306. I subtract and I get 16. Maybe 6. I get 6 as I'm having trouble today. 68 now. It goes in exactly 2 times even. So my answer here is 498 10,000ths. We knew where the decimal was because we just bring our decimal straight up. We just bring our decimal straight up with division. Here's another division problem, and I want to do this one together so that we're all on the same page. First number goes on the inside. So the other number goes on the outside. Based on that, using our fingers, how many decimal points are we going to move it over? How many places are we going to move our divisor over? Yeah, on your fingers. Perfect. Vahe is showing me on his fingers how much we're moving it over. Delaney is showing me. Lucia is showing me. Jessica's showing me how many times we're moving it over. Camilla, Marley. We have also Kylie who's showing it. We got Amelia, Ella, and Sophie who is showing it. We got more, but I didn't catch them all. So I move it over twice. I'm actually going to use black just to make it clearer. 1, 2. So I do the exact same to my division. I do the exact same to my division. I go 1, 2. Marjorie, when there's no number, what is the number? Perfect. It's 0. Now all I'm trying to do is find out how many times 2 goes into 840. So 2 goes into 8 4 times. That's 8. Perfect. I get 0. I bring down my 4. It goes in 2 times. That's 4. Excellent. I get 0. So I bring down my 0. Am I done just because I ended with a 0? Am I done because I know the 0? No, I still have to go to the end of my decimal. 2 goes into it 0 times. It goes into it 0 times. So my answer is 420. We can't have a decimal for our divisor, so we do the exact same for the dividend. We can't have a decimal for our divisor, so we do the exact same for the dividend. Here's a hard one. I want you to tell me which problem does not have the same quotient as the rest. You might want to think about patterns. Remember in the very beginning of one of our sections where we had the patterns in the warm-up, where it showed us with the decimals. So think about this first. Who can tell me by raising our hands? We should all know this first one. What is 49 divided by 7? Raising our hands. Camilla, what is 49 divided by 7?
7.
Perfect. So our first one is 7. Then the next one, I'm going to do on the inside 4.9 and on the outside 7. Another one, I have on the inside 49 hundredths and 7 tenths on the outside. And on the last one, I have 49 thousandths, and on the outside, I have 7 hundredths. So I want you guys to figure out which one does not have the same quotient as the rest. I want to do for this first one. Sophia, what did you get as our answer for the first one? Do we have to move the decimal at all for this first one right here?
I don't think so.
Nope. So we just bring it right up.
Yeah.
So
For the first one, I got 0.7.
perfect. She got 7 tenths. Excellent. We just brought our decimal up, and that's what we got. Lucas, what did you get for this one? Do we have to move our decimal?
Yes.
So how many times do I move my outside decimal?
You have to move it once, and then that means you have to do the same thing to the one that's inside the house.
Perfect. Bring it straight up.
I got 7 hundredths.
You got 7 tenths.
Oh, that's what I meant.
Yep,
Sorry.
he got 7 tenths. Exactly, he got 7 tenths. For my last one, I want, let's see, I would like, Vahe, do I have to move my decimal for this one?
That one, the bottom one.
Yep, the bottom one.
Yeah,
How many times?
2 times.
Perfect, 1, 2, so on the inside, 1, 2. Bring my decimal straight up. What did you get as your answer, Vahe?
Oh, I thought I didn't do it.
So 7 goes into 4. So we got 0 and 7 tenths.
Wait, so I was correct.
So he was correct. So the one that's different is A. We can notice based on patterns. We can notice based on patterns that we find that out. I want you to do this one. This is a subtraction problem. This is a subtraction problem. So am I going to line up my problem like this? What do we think? I lined them all up on the right. Is this, Lucia's shaking her head no. She's shaking her head no. What else do we think? Is this how I'm going to line it up? We got other people saying no. We got other people. No, I'm not going to line it up like that. How am I going to line it up then? Remember, for subtraction, the first number has to go at the top. Marley, how am I going to line it up?
adding 2 zeros at the end of 97.
Oh.
Zeros, and then line up the decimals with the 16 and 98 hundredths.
Yeah, so here she is, and look at, she said it so academically. We line it up like this. Even though 97 did not have a decimal, if it doesn't have a decimal, it's just right there at the end. And now I have to add these zeros. It's called annexing zeros, but we just add them so that we have the same amount of zeros. So as such, I want to ask you guys, can we do 0 minus 8? Yes or no? No. So I'm going to have to borrow. Can I borrow from 0? No, so I have to double borrow. What is the 7 gonna become? Abner, we take 1 away to donate it. So what is the 7 gonna become?
6.
Perfect. And the 0 becomes a?
10.
Yes. But now what do I have to do? Eduardo, now what do I have to do? I still have that first 0 that I need to deal with. So I gotta borrow again. What do I do? Yeah, and then that 0. Perfect. And now we're able to do our math. 10 minus 8 is 2. 9 minus 9 is 0. I bring my decimal straight down with addition subtraction. 6 minus 6 is 0. 9 minus 1 is 8. So we get 80 and 2 hundredths. Excellent. A hat costs $10.95. And a t-shirt costs $14.20. How much change will Brendan have left if he paid for both items with a $50 bill? I want to focus on this first sentence. What is the operation that I'm going to be doing here? Who can tell me what operation I'm going to be doing here? What is the operation?
Subtraction.
Marley, what am I going to be doing?
There's going to be 2 steps. First, you're going to add, and then you're going to have to subtract.
Yeah, I have to add and subtract. We know I have to add because this word and means add. And then when we're doing the change, when we find out how much change he has left, that's subtract. So our first step is to add those first 2 numbers, $10.95 and $14.20. 5 plus 0 is 5. 9 plus 2 is 11. I carry my 1. My decimal just goes straight down. 1 plus 0 plus 4 is 5. 1 plus 1 is 2. So he spent $25.15. Am I done with my question already? No. As Marley pointed out, I now need to find the change. He has a $50 bill. That's $50.00. And I'm taking away how much he spent. I have to do this borrowing again. 0, 0, 0. Oh my gosh, I have to go all the way there to borrow. This becomes a 4, 10, 9, 10, 9, 10. 10 minus 5 is 5. 9 minus 1 is 8. Bring our decimal down. 9 minus 5 is 4, and 4 minus 2 is 2. So he has $24.85 left after he bought his stuff. And Camilla got that in the chat, and Amelia wrote subtracting that as well. Here's this one. Pears cost 92 cents per pound, and apples cost $1.10 per pound. Gloria bought 3 7/75 pounds of pears and 2 1/10 pounds of apples. How much did she spend in total? There's 2 operations that I'm going to be doing here. Who would like to raise their hand and tell me the 2 operations I'm going to be doing here? What are the 2 different operations I'm going to be doing? Lucas, what are the 2 operations I'm going to be doing?
I know one of them is addition.
One of them is addition. And yes, what was the word that told you we're doing addition?
In total.
Yeah, in total means addition. Vahe, do you know the other operation?
Subtraction.
Not subtraction. Great guess, though. Not subtraction. What do we think? Marley?
Division.
Ooh, we're getting closer, but not division. So it's pretty much the last one, Lucas. Yeah,
Multiplication.
yes, Lucas says multiplication, who raised his hand. I am multiplying the money I spent by how much I bought. I am multiplying the money I spent versus how much I got, and then I'm going to add them together. So my first one, I'm multiplying $3.75 times 92 cents. I'm also going to be multiplying $1.10 by 2 1/10. When we're doing multiplication, do we line up the decimals or do we line them up to the right? Lucia, when we're doing multiplication, do we line up our decimals or do we line them up to the right? When we multiply, we line it up to the right. Just like if I had 25 times 2, I would write it like that. So when I multiply, we line them up to the right. I like the more digits on the top. So I'm going to write $3.75 and 92. It just so happened that these decimals got lined up there. Here I got $1.10 and I got 2.1. But now with multiplication, I have an extra step that I have to do now. What's the next step that I have to do? Who would like to raise their hand and tell me the next step that I have to do? Otherwise, I'm just going to pick people at random. Romina, what is the next step I have to do when I'm doing multiplication? I do have to multiply. She's not wrong. Marjorie?
So you multiply 2 by every number, like 5.
She's completely right, but we're skipping a step. We're skipping a step. I have to do something. Camilla, what do I have to do?
Add?
I do that. Jessica, what do I have to do?
You move the decimal.
Yeah, I moved the decimals all the way to the right. 1, 2, 3, 4. I moved it 4 times. So at the end, I'm going to move it 4 back. What about the second one? How many total times, show me on your fingers, how many total times am I going to be moving the decimal on the second one? So for the second one, I'm going to be moving it a total of 3 times. This one, 1, 2, 3. If you said 2, it's probably because you were just looking at the top one. So I'm going to bring it back 3. And then we just multiply like normal. Now we just multiply like normal. For time purposes, I want to do it like this. 2 times 5 gives me 10. Carry the 1. 2 times 7 gives me 14. Add the 1 gives me 15. 2 times 3 gives me 6. It becomes 7. Magic 0. 9 times 5 gives me 45. And I'll turn that into a 4. 9 times 7 gives me 63. Plus that 4 gives me 67. Then I have the last one, which would be here. 9 times 3 is 18, plus 6 gives me 24. I got called out because I was doing it 9 times 2. It's 27 plus 6 would give me 33. That's why I was like, this is not the right answer. We're adding these together. We get 0, 0, carry the 1, 5, carry the 1, 4, and 3. So I'm going to get rid of all this right here for a minute, and I'm just going to put it at the top so that we can see it. We get 3, 4, 5, 0, 0. But I had moved my decimal over 4 places. So I'm going to move it back 1, 2, 3, 4. So I get $3.45. For this second one, it's pretty easy. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. Magic 0. 2 times 0, 0. 2 times 1, 2. 2 times 1 is 2. I add these together. 0, 1, 3, 2. I got to move my decimal back 3 places. 1, 2, 3. I'm going to get $2.31. And as Lucas mentioned earlier, in total means to add 6, 7, 5. So she spends $5.67 on fruit in total. Here's another multiplication problem. Remember, with multiplication, we line it up to the right. 25 and 0 and 4 hundredths, and then 3 and 5 thousandths. So I line it up just straight to the right. On your fingers, how many total times am I going to be moving the decimal? On your fingers, how many total times am I going to be moving the decimals? So the total amount of times for both of them combined is 5. 1, 2. If you put 2, that's because you were looking at the first one. 3, 4, 5. We're going to do this multiplication really fast. 5 times 4 is 20. 5 times 0 is 5, or 0 plus 2 is 2. 5 times 5 is 25. 5 times 2 is 10, plus the 2 is 12. I'm going to look at a placeholder, but they're all zeros. I'm going to do another placeholder, but they're all zeros. I'm going to do my third placeholder. Finally, we can see I'm just going fast. And then lastly, we get 3 times 4, which gives me 12. 3 times 0 is 0, plus 1. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. So I'm going to add these together now. I add these together. Like I said, I went a little bit fast, but with those zeros, we have the placeholders. I add them, I get 0, 2, 5, 4, 2, 5, 7. But I need to bring it back. I wrote 0 there. I need to bring it back 5 times. So I bring it back 1, 2, 3, 4, 5. So my final answer for this problem, I get 75.2452, or 2,452 10,000ths. This is our last problem, you guys. Stay, I want to set this up for us. Our outside number, this is our inside, the first one. So our outside number is this. How many times am I going to be moving my outside decimal? Show me in your fingers. How many times am I going to be moving my divisor's decimal? How many times? I'm going to be moving my divisor's decimal 4 times. 1, 2, 3, 4. Right to the end. I do the same thing here. 1, 2, 3, 4. No numbers means 0. And I'm just going to carry that straight to the top. 24 goes into 0, 0 times. 6, 0 times. 60, 2 times. That's 48. I subtract, I get 12. I bring this down. 24 goes into 120 5 times. It's exactly 120. I get 0. I still have more to do. I bring down my 0. It goes into 0 0 times. Do I have to do any further? Do I even have anything left to do? No! So my answer is 250. So just remember, with multiplication, we line them up to the right, bunny hop all the way to the right, multiply, and then bring them back the same amount of times. Addition, subtraction, we line up the decimals, and division. Divisor cannot have a decimal, so we get rid of it, and we do the exact same to the dividend. Excellent work, you guys.